Hey everyone, in this video, let's go through question 213, House Robber 2 on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, you're a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. All houses at this place are arranged in a circle. This means that the first house is the neighbor of the last one. Meanwhile, adjacent houses have a security system connected where it will automatically contact police if two adjacent houses were broken into the same night. Given an integer array nums representing the total amount of money at each house, we want to return the maximum amount of money you can rob tonight without alerting the police. Okay, so we've actually done a similar problem before. We've done the problem House Robber 1, and in House Robber 1, essentially the description is exactly the same, but the only difference is that the houses are not arranged in a circle. So what this means is that, for example, this last house is not connected to this house. So for example, in this last house, if we rob it, it didn't stop us from robbing this first house. But in this case, we actually are stopped from doing it. In this place, because it's arranged in a circle, you can kind of think of it as this house and this house, they're kind of connected. And so how can we go about doing this question, right? So we can see the examples over here. You cannot rob house 1, money 2, and then rob house 3 because they are adjacent. So really, if you think about it, if there's 3 elements, then the only thing we can do is rob the middle house. And for example, similar to something like this, you can rob house 1, and then we can rob house 3, and then we can't actually rob this one regardless, but even if we wanted, like even if we did 2 and then this one over here, it's still kind of less than 4, so it didn't work. Okay? In this case, what can we do if we have these 3 houses here? Well, in these 3 houses, well, I made a mistake. I said if there's 3, then choose the middle one. But actually, it turns out that we can just choose the last one in this case because it is the maximum one. But we cannot rob any other house in this place. Okay, so how can we go about doing this question? We've done a similar question in the past, which is house robber, and so I have a video for that. So check that one out because we went in depth about like how we can solve it first using recursion, and then we worked our way towards dynamic programming. So I'm basically going to go ahead and just illustrate this solution that we have here. So what did we discuss? So in the solution that we had with the recursive case, maybe I can just go through this first of all. So let's say we had like a house, right? So this is our entire street. This is our entire street. Okay, this is our entire street, and we want to determine if we could rob house number n. If we can rob house number n, which is the 6 in this place. Now, if we wanted to rob house number n, then what we could do is we know that we cannot rob the house number j, right? We cannot rob house number j if we want to rob house number n because it is directly adjacent to it. So what we realized was that if we want to rob house number n, then we want to find the best answer till house I. Basically, the best answer till 2 houses in the past. 2 houses in the past, the best answer till this, and then we want to add on the money for house n. Now, it's completely possible that we decided not to even rob house I. So even though we are finding the best answer up till house I, it's possible that we didn't even decide to rob house I. So that's just one thing to note. But if we did want to rob house n, then we want to find the best answer until house I, and then we want to add in house n. Now, if we don't want to rob house n, then we can just take the answer that is in house j. So basically the best answer up till this point. And again, this doesn't mean that we've robbed house j. It is simply the best answer until this point. So for example, what does that mean? Well, if you take a look at this one, and maybe I can put this over here. So let me take a look here and put this over here. So let's say we have something like this, right? And we want to determine if we can rob house n. So here, this is house I, and this is house j. Now, what is the best answer here? The best answer is actually 11, right? It means we can rob this, and then we can rob this. So the best answer here is house 11. But if you think about it, here, if I'm at house 9, I want to know the best answer up till this point, house I. Now, no, we are not robbing house I in this plot, in this part. We might as well, if we wanted to, but we're not actually doing it, because if we did it, if we robbed house I, that means that we couldn't rob this house over here, this one over here, and so we couldn't arrive at the maximum solution here. Similarly here, we're actually not even robbing house j. So even though we're finding the best solution till this point, we're not actually robbing house j. Okay, so that's just kind of one of the things we discussed about. And anyways, I don't want to go too much more detail into this one. You can definitely check out the video where we discuss in detail how we want to approach this problem. But let me go ahead and copy this solution that I have over here. I'll go ahead and copy the solution that I have. And what I'm going to do is I'm actually going to put this inside of a helper function. So let me just call a helper function, def helper, And what do I need to pass in? It looks like I'm just passing in the nums themselves, right? So self and then nums. Okay, so now it's inside of a helper function. Now, why did I put it inside of a helper function? Well, notice in this case, right, like what we are given is that the houses are placed in a circle. So really, if you like think about it, let's say like we have like a bunch of houses, right? Let's say we have like a bunch of houses here. If you think about it, at no point can we rob this house and also this house. So really, it doesn't even make sense for them to be in the same array because we can never rob like the two adjacent houses at the very end, right? So in this case, why don't we maybe divide the subproblem into two problems? Maybe we can figure out the best solution where we consider the first element, but we don't consider the last one, and we consider the best solution in which we consider the last element, but we don't consider the first one. And we're allowed to do this because under no circumstance will we rob both of the houses, right? So if we rob this one, we cannot rob the 3. If we rob the 3, we cannot rob the 5. So really, it doesn't even belong in the same array. We can just consider the best scenario in which whatever the answer is here, maybe in this answer it's like x, and then we can consider the best scenario of whatever the answer is here. Maybe here it's y. And so if you think about it in this way, we can just take the best answer of x and y, and then that would be our solution. But what this kind of looks like in code is the following. So what we can do is we can actually check. We can check that, first of all, if length of nums, let's maybe simplify this. If length of nums is equal to, maybe we can just actually go ahead and copy this, right? So let's go ahead and deal with the case where length of nums is greater than 3 or greater than 2, right? So it's at least 3. If it's at least 3, then I know that at least, like in the minimum case, I will have 2 elements, right? 2 elements. So I can go ahead and process them. So what can I do in this case? Well, I will just return the maximum of consider first house. This will be self.helper. We'll consider nums from 0 all the way to -1. So this will basically consider everything except for the last element. And here we will do consider last house. And so here we will have self.helper, nums 1, and then onward. So basically here we'll consider all of this. And so then I can just return the maximum of these two, where I'm considering the first house, and then I'm considering the last house, but not the first one. And so this is all there is to this question. If you think about it, it really makes sense, right? Because these two, the first index and the last index, do not belong in the same array because we can never rob both of them. So we don't really even need to consider both of them as part of the one question here. So anyways, this is how we do this problem. And again, if you have trouble understanding the house robber, then go ahead and watch that problem to understand how we can better go about doing that one. Okay? Thanks for watching, and let's quickly discuss the time complexity. So looks like the time is just O of n, right? Because we're just going through the array, and we're doing it twice. So it's technically O of like n plus n 2n, but O of n is what we can do. And then the space is the same thing because we're storing it in the array. Okay, thanks for watching.